Hey, Josephine, good to see you here. We're about to start up some material. Josephine wonders if we can go over Canvas content quiz number 7 for Stats 101. You bet. Let's do it. This is a great way to learn the material and practice what we need to know. I think this is the last Canvas content before the test, right? But how is everyone doing? Let's reset MuBot here. Let's start giving out some points. Let's go here. And let's check it out. MuBot is being reset, a study of waste. You bet. We can do that one here after the Canvas content. Let me put it on live chat right here. And so let's go in, get the Canvas content going, and then we'll hop back to some chapter 14. Here we go. Canvas content getting loaded up. Canvas content number 7, sampling, some sampling distributions. Here it is on the screen, 100 points MuBot, chapter or Canvas content, number 7. Here we go. Okay, so for the Canvas content, this is on the sampling distribution of the sample mean and the sampling distribution of the sample proportion. So I want to point out some key things right here. These chapters are very much your knowledge of mathematics. So you need to know the formulas for these chapters. The formulas for these chapters are the following. There's part of them. For the first chapter, chapter 13, sampling distribution of sample proportion. The formulas are as follows. Mu p hat, which is what we expect to see when we take a sample proportion, is equal to p. The second formula is standard deviation, which is the variation in a sample proportion, is equal to p times q over n square root. I'm going to highlight each thing as I talk about it real briefly right here. This is the expected value of a sample proportion. That's like, I'd say if I take a sample, I'd expect to see this in my sample. This is the true proportion, which would be something like 20% of UT is from Knoxville. We know this. This is the truth. Now, what is Q then? If 20% of UT is from Knoxville, what is Q? So good practice right here. If 20% of UT is from Knoxville, then what is Q? Like we're saying we know this. We know 20% of UT is from Knoxville. 20% of the students at UT are from Knoxville. That is a fact. That is the true proportion. So then what is Q? Q then is what? This is the quick game we always play, the P-Q game. If we know P, then Q is 1 minus P. So Q is the complement. It's the other side. If P was 20%, 20% of UT students are from Knoxville, then what is Q? Q would be the complement of P. So if P is 20%, Q, Josephine right there, great answer, some 100 points in the chat. Q is going to be 0.8. Oh, N8, we'll do that right after this. Thank you so much. And then the sample size is how many students we talk to. So these are the formulas you need to know, and that's what everything is right here. This is the variation in a sample proportion. This is the true proportion, like 20% of UT students are from Knoxville. 80% of students are not from Knoxville. What did you say about the chapter? Oh, we removed it. So if you reload it, it should give you credit. Tell me if you don't get credit. We removed the 4th question. Good stuff right there. And then this is the sample size right here. Now the other formulas are the chapter 14 sampling distribution of sample mean. And when we do the sampling distribution of the sample mean, we're asking a what question. We're not asking, are you from Knoxville? We're asking a what sort of question. I'll write the formulas right here that you need to know for these. This is mu y bar equals to mu, and the other one is going to be SD y bar equals to sigma over square root of n. I've had people tell me for these problems, wait, what is P and Q? There's no more P and Q for these problems. There is no more P, no more Q for these problems, because all of these questions right here are no longer about, are you from Knoxville? They're all for the sample mean. That's the sample mean right there. The previous questions were for the sample proportion, and that's what we would expect for the sample proportion. So this question right here is, what do we expect in a sample mean? This is the average of sample means. What do I expect for sample means? And I expect the mean. Oh, Tiffany, we'll fix that too for you. I'll go ahead and fix those after this one right here. We'll do some more quiz and we'll finish that up. We'll make sure it's fixed for Michael and Tiffany right there, and also NH8. Sorry about the problems right there, but I definitely thought that problem went beyond the scope of what we were doing. So with this right here, if I tell you that UT students have a GPA of 3.7, and that is a truth, I have just told you the true mean. And that's what you would expect to see if you took a sample. So the true mean would be something like UT students from the registrar have a 3.7 GPA. That's the true mean. The standard deviation would be the registrar also tells us that the variation in GPAs is 0.4. That is the true standard deviation. So then we're asking, if we take a sample size of size 100, what would we expect the new standard deviation to be? So try solving this really quickly right here. If the original standard deviation was 0.4 and we take a sample size of 100, what would the new standard deviation be? Yeah. So yeah, it should do that, like with reloading. Great job, Michael. Yeah, so don't worry about the question being there. But no, it should do it. A lot of people have said reloading it is fixing it and giving the credit for the question. You might just go ahead and answer the question or something like that, but it should like omit it and still give you the 100. So it should like go through, omit the question, and still give the 100. What would the new standard deviation be? If the registrar tells us that UT students have a 0.4 standard deviation in GPA, we go out and sample 100 students, then the standard deviation we would expect, or the standard deviation for the sample mean would be this. Exactly, Josephine, crushing it right there. So with this knowledge out of the way, we're pretty good to go on these chapters. Like this is all the formulas we're doing right here. These are all the formulas, and we understand hopefully what the notation means, because once again, a big step to solving these problems is the notation and knowing the difference between, are we asking a quantitative question or are we asking a categorical question? Let's go ahead and take a look at this quiz right here and see if we can answer the questions now. All other things being equal, the larger the sample size, the smaller the standard deviation of the sampling distribution. What do you notice with these equations? Yep, perfect. What do you notice with these equations? That if sample size gets larger, what will happen to the standard deviation? If sample size gets larger right here, look where sample size is at. If sample size were to get larger, what would happen to these standard deviations right here? Just think where sample size is at. It's in the denominator of these equations. So if the sample size gets larger for either of these, all else being equal, we're not changing anything. We're just saying it'll get smaller. Exactly. So is this a true statement? All other things being equal, the larger the sample size, the smaller standard deviation of the sampling distribution. That is super duper true. The three conditions for the sampling distribution must be met in order to calculate p hat. Why do we meet the conditions? So why do we have conditions? We'll look at some notes right here. We have conditions. Condition 1, random. Condition 2, 10%. Pause. And then condition 3 is either going to be success failure or large enough n. So the large enough n, hello, good to see you here. Good to see everyone here. Casey, or CC and Ditto. So why do we meet these conditions? The whole point of meeting these conditions is why. Why do we try to meet these conditions? For either one of these, the whole point of meeting these conditions is to do what? To use the what? The whole point of meeting the random 10% and whatever the third condition is, the whole point of meeting these conditions is to use the what? We don't need to meet the conditions to calculate p hat, I'll tell you that much. The whole point of meeting these conditions is to use what? Why do we meet the conditions? So that we can describe it with the what. To meet these conditions, we can then describe it with the what. As soon as we meet the conditions, we can then start describing it with the what. What is this? What is this? What is this? The normal curve. Great job, CC, right there. Excellent work. So this is false. You do not need to meet the conditions to calculate p hat. P hat is the what? What is p hat in notation? Like this is the practice we need. What is p hat? If you see p hat, you're like, what is p hat? So p hat is the sample this. So what is p hat? It's solved by the formula x over n, which is the number of successes over the number of trials. So if I go out and talk to 100 UT students and 25% of them 25 of them like Taco Bell, it'd be 25%. If I talk to 100 UT students or 50 UT students and 10 of them like Taco Bell, it'd be 20%. It's 10 over 50. So p hat is the sample what? You don't need to meet conditions to calculate it. Sample proportion, great job, Michael, right there. You don't need to meet any conditions. You just say, I talked to 50 students, 10 like Taco Bell, the sample proportion is 20%. You don't need to meet conditions to calculate that. It's just how many students out of the total said something. So that does not need to be met. Ooh, I love this. I love these questions. A manufacturing company would like to investigate the effect of a new supplier of raw material to their product. The company makes 7,000 of these items each day, and the new supplier is much less expensive than the current supplier. If the rate of defect remains unchanged with the new material, They will use the new material for their analysis. They take a cluster sample of 500 items made from the new supplier. If the defect rate is 3%, is the success failure condition met? What two quantities do we need to calculate for the success failure condition? What two quantities do we need to calculate for the success failure condition? This sounds like a super hard problem, and I swear usually people just guess at this. But our first step for any of these problems is to mark the notation. So the first step for any of these is to mark the notation. Great job, Michael. Michael, you're earning crazy points today, man. Keep it up. Michael has it. We usually don't talk about that other one. That's there to trick you. So Michael's got the answer right there. Yeah, definitely. You bet, Tara. You bet. Thank you, Tara and everyone. We're going to do some more quizzes after this. We got Tiffany has a question from the quiz, and we're going to do more questions. So thank you, everyone, for being here. Great work. And so who can calculate? I'm doing it in my head. Who can calculate what NP is? So the success failure condition. Condition 1 is random. Randomly select the items. Condition 2 is 10%. Less than 10% of the population is sampled. We meet that because 500 is less than 10% of 7,000. And then condition 3 is success failure, which says for this that, and so success failure, really? Success/failure. So NP and NQ both greater than or equal to 10. Okay. So what is NP right here? Just take a moment. We have N already marked. What is P? So what is NP? Take a moment, solve this. Oh, yeah, we do. You bet. Got 3 questions lined up. Thank you, Haley and everybody. Let's throw some more points. Solve NP for me. Solve NP. Michael, just crushing it as per usual. Amazing work. It is 15. You're just taking and plugging in here. N is 500. And then this is 0.03. And then NQ is 500 times 90.97. It's a point. So this is 15 right here. Put it down here in green. That's 15. And that's 485. Because they both have to add up to 500. If you add those up, they add up to 500. Do we meet it? Do we meet at least 10? Are we good here? Do we have at least 10? Are these at least 10? That's what we're looking at. That they're, when we solve NP right here, remember we marked our notation. So we see, is there at least 10? That's all we're looking at. Is that 10? At least 10? Is that at least 10? Yep. Good to go. We got it. That's at least 10. Yep. According to the central limit theorem, which of the following will happen to the sampling distribution of the sample mean or sample proportion, whichever one we're looking at? 2 things will happen. Big review from class today. What 2 things will happen? I want you to put it in the chat. We talked about this a lot in class today. The 2 things that happen with the central limit theorem. Once again, sometimes we teach to the test. What are the 2 things? This'er and this'er. More this'er and more this'er. And we saw this looking at the applet. Haven't done that yet. We'll do it right between these columns right here. I'll take a look and I'll make sure to find that. We're almost done with this. I might do one more quick version of it. It'll get more normal and we'll also get water. You are correct. It'll get more normal and also get more water. 2 things. It'll get more normal and tighter. And so the distribution will get smaller. What is it? Which of the following will happen? Oh, the mean. It's saying the mean. It's tricking us. Ooh. The standard deviation gets smaller. If this said SD, that's a trick right there. I was like, wait, what? The standard deviation gets smaller, not the mean. The mean will stay the same. The mean, mathematically, we talked about that earlier. The mean, it's on the previous one. The mean stays the same. The standard deviation gets smaller by a factor of square root of n. That almost caught me. I was like, wait, what's wrong right here? The standard deviation, the distribution will get more normal, and the standard deviation will get smaller. The standard deviation will get smaller. Good trick right there. The 10% condition states that we need to sample less or more than. More normal, yep. It's going to get more normal as sample size increases. One of the things is central limit theorem. The 10% condition states what? That we need to sample less than or more than. So we need to sample no more than or more than 10%. The 10% condition states that we need a sample, which is confusing. It deals with mathematical issues with finite populations. It's a lot of theory that goes into this one. But we need to sample what? No more than or more than? Less than, yep, which is no more than. We'll do one more version of this, and then we're going to correct people's quizzes. We got that 10 out of 10. Show me that 10 out of 10. Let's do one more version of this and see what we get. Really good quiz right here. All else being true, the larger the sample size, the smaller standard deviation. Very true. Sampling distribution. Let me zoom out a little bit here. Correct, no more than. We don't want to sample more than. We sample less than. Sampling distribution rules allow us to calculate a confidence interval for the true proportion. Why is this one on here? Because we used to... I need to like go delete that. Let me read this question carefully because I don't even like this question. Sorry, like today's Brown Variant's like, I don't like this question. I don't like this question because it bridges the gaps between the chapters, but also this is where the statistician in me is like, It's on your quiz. Well, we'll find out the answer very quickly right here. Sampling distribution rules and conditions allow us to calculate a confidence interval for the population proportion. Condition 1 is what? Who knows condition 1? Condition 1 is what? This one is so iffy on how I'd answer it. Condition 1 is what? I'm going to put false. Wait till I put my answer. Random. Always condition 1. Condition 2 is 10%. Always 10%. Now we pause and we say we're doing proportions. What is the third condition? This one is so... We pause, yep, because this one is proportions right here. So it's going to be the what condition. So you already know this condition right here. This is a chapter we haven't done yet. I need to go remove this from the question bank on this. But this is proportions. So now here's the thing, though. Since this one is doing confidence intervals, the condition changes slightly. The condition now is no longer NP and Q. Since it's confidence intervals, it's NP hat and Q hat. Because if we're doing confidence intervals, we don't know the truth. So the only change to it is we're using NP hat and Q hat. So in truth, this is a slightly different condition that goes by the same name. It's still success failure, but it's NP hat and Q hat. So I'm going to put false. Don't put your answers in yet because we're going to find out the answer to this one very quickly. This one I think is the one we just did. We do meet the condition. We did this one earlier. Check out earlier in the video to see that one. The condensed presentation states that we sample no more than. The central limit theorem relates to which of the following conditions? The central limit theorem is going to be related to the... I'm going to talk to Terry about this. The nearly normal, which I guess that makes sense. But let's see if that one was false. And the answer is... It's true. And I'm very unhappy about that. I need to talk to Terry about this. I'm going to send him an email and say I don't like the way this question is worded. This is just... I don't like... People make different questions and they want to imply different things. I really don't like this question because the success failure condition for confidence intervals is NP hat and Q hat. The condition goes by the same name as the success failure condition, which I think this is what this question is trying to point out. So when you do confidence intervals for the sample proportion, condition 1, random. Condition 2, 10%. Let me go in and edit this quiz right here. I don't think anyone's going to be merging quiz banks. And I need to talk to Terry about to make sure this is not on the test on Wednesday, because these questions are drawn from the test. 2 seconds right here. I need to edit quiz banks. But how's everyone doing right there? Sampling distribution sampling will have the same... So what will it have? It'll have the same what? Everyone answer in the chat right there. So figure it out right here. I'm going to ask you in the chat. The sampling distribution and the sample mean will have the same what as the original distribution. And 8, you got it. It'll have the same mean. The mean does not change. The mean does not change. I'm going in here editing a few things. I think it's being chosen out of this. 2 seconds. I'm editing up some quiz. I think I got the 2 questions. Okay, that one's removed. I'm looking over the questions. Okay, that's got that. And they need to fix it for the other class really quick, too. And... okay, delete this one. Oh, did I save it? Okay, I don't need to save it. Cool. Okay, I think it's saved now. If you got those questions, tell me. Okay, I need to fix this for the other class real quick. Fixing it up. How's everyone doing today? Where you have to go in and fix things. How is everyone doing today? We're going to do some more My Pearson here in a second. Canvas content. Edit. Questions. Question bank. So it should be fixed right there. Remove that. Well, thank you, Sam, right there. Busy, busy, busy day. I can't imagine having kids. Like, it'd be so busy. It'd be so busy. Like my brother, he's got 2 kids, and he's just like, I called my brother recently, and Tolliver answered, my nephew Tolliver, and he was like, "Hey, Uncle Brian," and I hear my brother in the background, "Tolliver, we got to get ready to go. Tolliver, get your shoes on, Tolliver." And he's like, "What are you doing, Uncle Brian?" And I was like, "Tolliver, your dad's in the background telling you got to go." And he's like, "Yeah, I know. How are you, Uncle Brian?" And I was like, "I'm doing good. I'm doing good, Tolliver. I'll let you go. Your dad's calling you, man. Your dad's saying we get ready to go. I don't want Uncle Brian to get you in trouble here." So Uncle Brian's not trying to get little Tolliver in trouble. Okay, let's go take a look at some. Let's make sure everyone's okay. So we got the Canvas content fixed up, looking good right there. And who had questions on My Pearson? I think some people were saying their My Pearson was a little bit weird. Like, NH8, if you're still here, did we get your My Pearson fixed up? NH8, we're gonna fix up my people's My Pearson, then we're gonna do some My Pearson problems. What's your Pokemon trainer ID? Of course, I'll put it in the chat right here. What legendary raids? What? 13 and 14 for me. And you're in section 004. Didn't I put it in the gaming chat? Let me go to the gaming chat right here real quick. And so we're going to fix up people's My Pearsons. It's on the gaming chat. I'll put it in this chat too if you want to add me. There you go, Tara. In the chat. Pokemon trainer ID. And a little bit of fun today. Relaxing here. And you're in section 004, right? NH8 13? Wait, people were saying do chapter 13? I'm so confused. You said H. I'm looking down the H. Trying to find you. Oh, I think I found you. Okay. You're saying chapter 13 and 14? Okay, wait. What? Sorry, I'm trying to find it. I see the school referendum stuff. I'm going to go in and mark. Oh, I see it. You just have to do question 1, it looks like. Okay. N8, it should be saved for you right there. N8, tell me if that's fixed. So, 004, yeah. Awesome. It should be fixed for you right there. I got a shiny Ghastly yesterday. What other questions do people have? Let me know. We're just fixing up My Pearson at the second before we hop in and do some My Pearson questions. Is everyone else's My Pearson doing well? All fixed up? Is everyone else's fixed up? Nate or N8 should be fixed right there. Should be good to go. Was there something on 14 also? Explain to me in the chat if something else needs to be fixed. Fix your chapter 14 homework. You got it. Let me go fix that real quick right here. We're just fixing people's homeworks. That's what we do right here. Let's go fix the chapter 14. And there we go. And hopping in. And 3, 2, 1. Should be fixed. Reload it. Check it out. Should be fixed. Anyone else need anything fixing? Can we do? You bet. Still can't access it. Reload it. So N8, it should be fixed. Tiffany, it should be fixed. Should be reloaded. I think we'll do Tiffany's question first. Tiffany wanted the waist size question, and then we'll do Tara's question next. And then I think there's a few more. We definitely got some more good to go right there. So N8, tell me if it kind of just shows me submission details. All good. Tiffany says it's all good. Try reloading it, N8. Try like reloading the page or stuff, and we'll check that out here in a little bit. I close out of it, reload it, but it should have 100 for it. Let me double check. Unless I just gave someone else 100. It's possible. Let me do this. 1 second. I'm just going to change the score flat out. Since it's causing issues. Okay, I just changed it flat out. It should be changed. Hopefully it lets you do it if you want to repractice the homework. But chapter 14 right there should be 100% fixed and changed out for you right there. Let me know if it's not fixed and changed out. Let's go do that waist size question. Here we go. Chapter 14 quiz. Sampling distribution and sample mean. The waist size question. And let's take a look at it. I'm loading up there as we go. Here we go. Waist size question. Tiffany, which one do you want to do? There's 2 waist size questions. Let's go check this out right here. Here we go. Chapter 14 waist size question. Here we go. I think that might be a separate thing. Can you explain to me the problem N8 in the chat with the chapter 13? And I'll maybe go in and like submit it or something. Tiffany, is this the one you want to do right here? Yes or no? There is the other one. Did you want to do this one, which we did in class, which we can do again? Or do you want to do this one right here, which is a different waist size problem? There's 2 waist size problems right here. There's 2 waist size problems. Which one do you want to do? Is it this one right here? I don't want to switch screens too much. This is the other one. We haven't done this one yet, so I'm assuming it's this one right here. Chapter 14, waist size problem. Another version of it right here. So let's go ahead and knock this one out of the way here. And we have right here that we have a distribution. Awesome. Great stuff right there. Some 50 points in the chat. So a study measured the waist size of 963 men, find a mean of 36.37 inches and a standard deviation of 4.07. So what is 36.37? If this is going to be for all the men they talked to, so this is every single person they talked to in the population. So it's not all men of everything, but they're going to talk about samples being taken from this. This would be what, since it's all men that they talked to? It's like, I know that's kind of still a sample, but they're considering it now a what for this problem, which is a little bit odd. I do admit that. But they're considering it a what for this problem now. So this is all men they talked to. That is the what right there. That is the mean for everybody. So what is that in notation? Remember, always start by recognizing your notation. We're just kind of doing this right here by seeing it. We're saying, okay, that is the this. What is this right here? 36.37 would be the what for this. Going to our notation sheet, we can see some important notation that we should know. And what is it that we have just found? It's going to be, Kayla right there knows it's the mu. That is the mu right there. When we say 36.37, that is the mu. And then the standard deviation is going to be whatever they give. So those values that they're showing up there at the top, since we're doing the sample mean, we're asking what is your waist size? Remember, this is a quantitative question. This is going to be mu, so we could figure out the mean for the distribution of the sample mean, and this is going to be the standard deviation, which is sigma. This is not the standard deviation. This is sigma because it's the truth for the population, which is sigma, which will allow us to find the standard deviation in a sample of a certain size. So this standard deviation right here for the sample mean is from a sample size. So with this right here, let's click this. It says, describe the distribution of waist sizes. Is this skewed to the right, skewed to the left, or is it symmetric? How does this distribution look right here? Right skew, left skew, or symmetric? Remember, right to the high, left to the low, whatever way the tail goes. Right skew. Oh, thank you, Emma. I appreciate that right there. It's my sports shirt. I can wear it to anything. Sports. So right to the high, left to the low, whatever way the tail goes. Right to the high, left to the low, whatever way the tail goes. What way does that tail go? Does it go to the right, which is to the high side? Right skew, that is a right skew distribution, right to the high, left to the low, whatever way the tail goes. So that is a right skew because right to the high. And that's the high side. What do we mean by high? The higher numbers on the curve. Just make sure it's always oriented that way. Like sometimes people can turn it weird ways. And then it confuses you. So these simulations do demonstrate. Simulations will show reality because they simulate reality, unless we do something really weird. To demonstrate what the central limit theorem says about the sampling distribution model for the sample means, all the histograms are centered near. Oh, so wait a minute. What does not change about the distribution? As we do this, what would not change about the distribution? What would not change about the distribution? And you see this in the simulations. What does not really change? Oh, yeah, definitely, Jenna, you bet. I think we're going to do Tara's question next, then we could do Jenna's. You got it, Tara. I mean, Jenna and Tara. What would not change about these distributions? The mean doesn't change, Tiffany, you got it. The mean does not change. As n gets larger, the histograms will start to do what? As n gets larger, and we're showing the notes right here, as n gets larger, the what will get whatter. As n gets larger, the standard deviation, the histograms are going to become more normal. So they're going to get more normal, and the variability is going to decrease. So this is the two things of the central limit theorem here that states that the distribution will become more normal and the standard deviation will get smaller. If you look, it's got a right skew, looking more normal, looking super normal, and also it's getting tighter. The way to tell it's getting tighter right here is to look and see that this goes from 28 to 48, this goes to 32, and I wish they put an upper number. But it's getting more normal and tighter. Awesome, thank you so much. See you for now, N8, thank you so much. 100 points, N8, appreciate you. All the positivity right there. Oh, good. The histograms are fairly normal at a sample size of 5, which coincides with the next question if we were to do it. So that kind of gives a hint if you do the other question that they're pretty normal at a sample size of about 5, and we should ace it. We got that 100. That's the way we like to roll right here. Great stuff right here. Excellent questions. I think the next question was from Tara. So Tara, we're going to work on the next question. Let me go find Tara's question. Tara's question was... Tara. Oh, and then we have Haley's question too. So we need to go Tara, Haley, and then Tara. Can you put your question in the chat again? Okay, can we do the next one? Chapter 13. The proportion of adult women in certain geographic the proportion of adult women in a certain geographic region is approximately. That's chapter 13, is it? I'm trying to think. For my brain's like trying to remember which one that is. Let's hop over here. I'll find the proportion of adult women. I'm trying to remember that one. I haven't done that one in a while, I think. The proportion of adult women question. Let's go find that one. Chapter 13, apparently. Thank you so much. Chapter 13, the proportion of adult women. Let's go find that. Chapter 13. It's like this one just like jumps out of my head. The proportion of adult women. Here's nearsighted children. Fundraising dinner. School referendum, which I think someone might have said. New restaurant. Market research, investment website. The person. Oh, it's the marketing research. Wait. Why can't I find it? Yeah, definitely. There's links on the exam, Josh. So there'll be links on the exam. Josh, thank you for asking. I think you can only have the links open on the exam. You can have a piece of paper open next to you. And Josh, 100 points, thank you for asking. Oh, it's the marketing survey? No, it's marketing research says switch their phone, unless this one changes. Okay, let me look again. Tara, can you email me a screenshot of this question? Is it maybe, let me check one thing. About phone company? Okay, cool. We could do the phone company one. Let's do the phone company. Tara, if you can email me a screenshot, we'll do that one. The phone company one. I just can't find it. Phone company one's pretty quick. So we'll knock this question out right here. Yeah, awesome. Thank you everyone for helping me keep track of these questions too. Let's check out the phone company research question, then we'll come back. Tara, we will do your question. We'll find it. Let's check this out. So a researcher for a phone company surveys 104. So what's the first thing we're gonna do right here? What's the first thing when you hear they survey 104? You're gonna immediately tell me, Brian, we should be doing what right here? You know the steps. You've got it down. If you've been practicing these problems with me, you know when you hear they survey 104, you're immediately gonna do this. You're just gonna be like, I am a robot. I am a robot. What do? Start labeling this. You say this and this looks to be notation. 104 is the sample size. And they know, finds that the proportion of customers who are likely to switch providers is this. And we are assuming that this is the true proportion. So that is assumed about this question, majorly assumed because we're in this chapter right here. So we need to find one other value to solve this whole problem. We need to find one other value. And great job, everyone right there. Jen, everyone, great job. What is the last value Brian needs to find? If I know that P is 0.16, Q is what? Q is 1 minus P, so who can find Q? I'm right there. I've almost got it. Q is going to be what? If P is 0.16, Q must be this. It'll be 0.8. And how do we get it? Just practice. Great job, Jenna. Excellent work. More points in the chat. So Q is 1 minus P. So if you're wondering how we got this, just take 1 minus that. Well, and if you get something 1 minus, it's the easy mathematics that's the toughest part. It's the complement right there. 1 minus P is Q. So they add up to 1. These have to add up to 1. If you're worried you did it incorrectly, just double check they add up to 1. So what is the formula? P times Q over N square root. This value right here is P times Q over N square root of the whole thing. So we're just going to plug in the values. 0.16 times 0.84 times, divided by. It's divided by. It's not times. And there we go. P times Q over N square root. P times Q over N square root. So that's going to be the answer to the first question right there, 0.036. 0.036. Now the last question right here seems super tough because it says, if we want to reduce the standard deviation by half, then how much would we need to sample? Well, we just think really hard and we say the answer is 416. We didn't think hard enough. What did I do? I thought hard enough, I just didn't do decimal rounding. 0.03595. 0.03, let me copy this number. Don't forget to round decimals. I would correct this for you if you get it wrong. That's that right there. Now we get it correct. But how did I get that second question? Didn't think hard enough. So how do we get this second question right here? And how was Brian able to solve this in his head? The second question is a really great theory question. So the second question, it's always today, my Pearson. Today is a very bad day for my Pearson, or for me. So much better than last week. Today's doing fine. So the formula here is P times Q over N square root, right? But I'm saying I want to get half of this. I want this value to be half of what it was. Does that make sense? Can you multiply these two numbers together right now, yes or no? Can I just go here and say, well, you know what this solves to? I'm just going to take right here and put this 1/2 inside the radical and do this. Can I just do that and multiply these two numbers to take a half and just say, let's just multiply that by a half? So I need to take twice the sample size because that's going to make, like this would mathematically solve to this right here. Can we just do that? Can we just multiply? Can we do that? Can I just say, well, just multiply the two things together? No, you can't. That's not the way algebra works. But what you could do is you could take this right here and you could square root it and square it. And is that the same thing? Like I'm doing and undoing it. Does that make sense? Does that make sense what I've done right here if I've squared it? Emma, which one? Explain in greater detail, Emma. I do not know which one you're asking about. Explain in greater detail, and we'll make sure to look at that, Emma. You got it. So now right here, we're doing 1 squared over 2 squared, which if we solve this, it's this. And this equals to... Does anyone see what Brian did to solve for his answer? What did Brian do to solve for his answer of 416? Remember, Brian got the answer of 416. So how did Brian get the answer of 416? How did I solve for 416? What did I do? If I say I want half the standard deviation, I have to take what? The sample size. So what did I do to the sample size to get 416? Which it always works out this way for this problem. So if I want half the standard deviation, I have to take 4 times the sample size. So all you're doing is just timesing the sample size by 4. So the answer is literally this right here. That is literally the answer, 4n. So you just take the sample size, multiply it by 4, which we've done up there, and all you would do, every time you do this problem, it does work out this way, that if you take 104 and multiply it by 4, you will get the answer. Does that make sense theoretically right here? That just the way the numbers carry across, if we want to take half the standard deviation, we have to take 4 times the sample size. Why 4? So here, I'll show it again real quick. The reason it's 4 is because we are saying, here's the current standard deviation. That's the standard deviation. P times Q over n square root. Does that make sense? That's the standard deviation. We want to take and make this half of what it was. Like, we want to take and make it half of what it was. But you can't just multiply those things. You can't just multiply those together. So we're going to rewrite 1/2. Like, 1/2 is the same thing. 1/2 is the same thing as this. Like, this is equal to 1/2. Does that make sense? This is 1/2. Because, reason being, it's the same thing also as this right here. If it helps to see it like this, that might make more sense if I write 1/2 like this. The reason we're writing 1/2 this way is now we can multiply it. Does that make sense? Like, this can be multiplied together right here because things can join into the radical. This squaring and square rooting is being undone. Like, all of these things right here cancel, but we need these done on this. So this is still 1/2 if you cancel everything out, but we need to do this so we can enter it into the radical. Like, we can multiply these things together now algebraically. So because they have radicals on them, they can be joined into the other one, and we would get right here P times Q, times 1 technically, but that doesn't matter. Times 1 is 1. The same thing rather. And then on the bottom here, we'd have 2 squared times n. The 2 squared is actually just 4, and that's the important thing that we're doing right there is we're timesing it by 4 to get half of the standard deviation. Does that make more sense, Kayla, right there? It's more of a math theory question that if you want half the standard deviation, you would have to take 4 times the sample size to obtain that. So the key thing right there is the 4 you obtain by doing half. But to join things in the radical, you can't just multiply by a half. You'd have to square it. I mean, you'd have to square and square root it because it has to be under a radical. Things to join under radicals to multiply together algebraically. So it's a little bit of math that we're doing. Sad days when we have to do mathematics. But for 2 things to go into a radical and be multiplied, this has to be under a square root, and this has to be under a square root. This is the same thing. If you're worried that this looks a little bit different, since they're both under radicals, this is the same thing as this right here. Does this all make sense? It's the same thing right there, and then you can join it together. The math theory on that was a little bit tough. We don't love a bunch of math theory on our test, but it's a decent question. Don't expect the test to do a bunch like this. Exactly, and so that's 2 squared, which is 4 right there, and so that is the same thing. That is the 4 coming from the 2 squared and then multiplying together. A decent question, but don't love it for a test. Don't love it for a test. Wrong button. Did we find the other question? Let's see right here. We're just keep rolling away, knocking out questions as we go. The next question was, Tara, did we find it? I sent the email. Tara, let me see this question. Tara, thank you so much. Tara Love says, here's the question. Sampling distribution. Oh, it's the homework. Oh, thank you, Tara. Tara, 100 points for everyone. I should have realized that the homework has this question that doesn't. I'm going to say thank you. There we go. I'm going to reply. Only got 40 emails right now. Okay. So, Tara, it was from the homework. Brian's brain's just not working today. As per usual. Makes Mike too much fun of myself. Tara, thank you so much. We're going to knock out this question right here on the Chapter 13 sampling proportion homework. So many different questions. I just clicked the wrong one. Chapter 13 sampling proportions homework. There's too many Chapter 13s and 14s. Proportion of women. We're almost there. We have found it. Let's go do it. It's another math question. Oh no. Math question, Chapter 13, sampling proportion of women. Let's go check this out. This is another mathy question. So what do you think is the first thing we're going to do right here? What is that first thing we're going to do? That first thing we're going to do with any sort of mathy question problem is we're going to do what right here? What would you do right here? What are you going to do for any sort of math question? What shall we do? The proportion of adult women's in geographical region is estimated to be 51%. Mark that notation right there. Kayla crushing it. So tell me what 51% is. Tell me what 200 is. Just tell me one of these. I'll do the rest. What proportion of the sample of 200 would you expect to be women? No way is it. Oh, it's complete multiple parts. Wow. Because I was like, is that the only thing it asks? Is that the only thing? I was like, we can do that very quickly. So this right here, it says the proportion of adult women is this in a geographical region. Yeah, we can do bank problem right here. I think Tiffany might have the next one, and we're gonna just keep crushing problems. If you make sure, you might have to remind me of your problems. This right here is P, which is the true proportion of adult women in a region. Q is the complement, 1 minus P. Just practice P and Q are complements. And Kara right there, Kayla, excuse me, great job. That is N is 200. So this is asking, what percent do you expect? And if you hear expect, you should be thinking mu P hat equals P. So what's the answer to this question? Use your notation. It's saying, what percent do you expect in a sample? So this is the word expect, because that's the mean. And then this right here is in a sample. So that's in a sample proportion, a proportion sample. So nice job, Casey. Glad to do this one. Knock it out. So what would you expect? 51%. That's it. Because it's P. That's the answer. So we expect 51% in a sample. So I'd expect 51% because that's the truth. If I took a sample, I'd expect to see that. What is the standard deviation? You might be saying it along with me. P times Q over N square root. P times Q over N square root. So we need to find, we have P, we have Q. We already have those numbers. P times Q over N square root. And we go here to 0.51. I'd love to go back, and I should watch a video of me teaching this years ago. I'd love to know the first instance when I just said P times Q over N square root. I don't know. Sometimes I do those things to help me memorize stuff too. There was a point when I would like have to like double check formulas. Like even teaching, I'd be like, wait, what is the formula again? There's the standard deviation, which is the source of the variation in this. So we're not always going to see 51%. I know, right? I've got some older videos of me teaching. I'd love to see, you know, it'd be really cool if I had it. The first class I ever taught. Oh my God, I'd love to see that. I'd love to see in 2010, the first class I ever taught. I think it was 2010, I taught a class for the first time. I'd love to see that first class, or just any video from the first semester of me teaching material. I'd like to see how bad it is. Like if I, not saying I didn't know the material, but like you teach something for 11 years, you learn it pretty well. You still have to learn how to round decimals though for my Pearson though. I wonder if Haslam would have that. I'll have to talk to Carrie Rohr. He's amazing. How many women on average would you expect to find in a sample of that size? Wait, what? Oh, wait, what? A lot's changed. Lots the same material-ish. We've actually changed up Sat-to-Win a little bit in the 11 years I've been teaching it. But man, it makes me feel old there. I've been teaching this for over a decade. But I do love it. There's a lot of material I love. We used to do things like, what's it called? We used to do experiment stuff. We used to do 2 sample proportion stuff. So some material we just didn't find as applicable. So we try to update and move with the times and do the best sort of things. We're always optimizing. So we do in stats. How many women on average would you expect to find in a sample of that size? I think it's just taking right here and it'd be 102. I'm pretty certain. Yeah, that's what I would do. That's what I think it's asking. It's an interesting question. If we expect 51% women, we have a sample size of 200. I'd expect 102 women. Now, that's not saying you will see this. It's just what we would expect. And that should be right there. Like it. A little bit. I just don't usually ask a question like that. It's just, you know, if we expect 51% women, if we sample 200, I expect 102 women. So just think about it theoretically. I expect 51% women. I'm sampling 200, and thus I would expect 102 women. Awesome stuff. I think, let me go to the next question. I know we had another one here. The next question I'm going to take is from Haley. Wants the new restaurant seat question, which I think is on the homework. Let's hop over to the main screen. Let's get that restaurant seat question, which I think is on the homework. We'll make sure we get a lot of homework questions done here. Bank question. No, it's not on the homework. Let's do the restaurant question, then please put your questions in the chat. The restaurant question is on the quiz. I know that one's a tough one. It's a tricky one where a lot of mistakes are made. And it's going to come down to marking that notation. We're going to get that restaurant question up and going. Please put your questions in the chat. And thank you everyone who is here, following along, practicing. Did we do part C? Yes. It was multiply the true proportion by the sample size. So CC, make sure to multiply. I know, Tara, when you see it, like, oh, really? It's like, okay, wait. Mu p hat equals p. SD p hat equals p times q over n square root. And then multiply p times n. So those are the steps to that problem. But then just make sure to, the more that you understand the theory, the more it kind of makes sense when you see it on the test. Because you don't want to get to the test and be like, what are they asking about? We know the true proportion. You're like, oh, that's p. What would we expect to see in a sample? Well, they're asking mu p hat. The more you do these questions, the more when you get to the test, it's like, oh, well, that makes sense. If you don't practice them, it doesn't make sense. Tiffany, put your question. It'll be next right after this one. Tiffany's got the next question. Tiffany, put which question you want, and we'll do Tiffany's question next, right after the seats at a restaurant. So let's check out the seats at a restaurant. Tiffany, you got next call question. Here we go. You know what we're about to do. You've been watching these problems. We are about to take right here and mark the notation. We're about to take and mark the notation. Let's go right here and mark that notation. Here we are. Yeah. So Tiffany, put your question next, and you got it. Help me out. This problem seems really difficult, but once we mark that notation, we can crush this problem. We got this. So tell me right here, what's the notation? Yes, you bet. Chapter 14 quiz, you bet. We'll do that here next. So who can help me out with any of this notation? You should just look at this and you should be like, a new restaurant is planning 121 seats. Ooh, that sounds like a sample size. The studies show, so this is the truth. Great job right there. Kayla has identified the truth according to research, 63% of people demand non-smoking. And the complement of that, which is 1 minus, is this. If you're ever worried, please double check your work. P and Q are complements. So we should know right here that we just take 1 minus 0.63. And that is going to be Q. An amazing work. Kayla earning everyone 100 points in the chat. Thank you, Kayla. This is the practice you need to when you get to this problem, we have it. So now we really just need to solve for two quantities. We're almost here. This problem's a lot shorter than it seems because it's only asking one question. So, and then Cece, we got there after Tiffany's. Thank you, Cece. Remember, Tiffany and Cece. Remember that. If I forget, people, remind me of that order. We'll do Tiffany's and then Cece's next. So we need to solve for these values. So these values I just marked right there, I'm going to write the equations in red, are going to be mu p hat equals to p. So that is going to be this value right here. And then we need to do SD p hat equals to p times q over n square root. And that's going to be this value right here. And then we're just going to plug it in. We're just going to plug in these numbers and solve out for mu plus 3 standard deviations. So what is mu? What is, like, so we're saying mu is mu p hat and mu p hat is p. So what's the answer to the first thing right here? So just follow the order. Mu is equal to mu p hat, because that's what the mean is going to be. And mu p hat is equal to p. What's the first answer? The first number we're looking for is what? Yawn, get some energy. It's 0.63, because that's what p is. We identified it. We said, okay, well, that's the mean of the distribution. So the first number here is 0.63. Now we just need to find sigma, which I'll write it right here. I'm trying to put it in a spot where you can see it. So this is going to be p times q over n square root. P times q, there's q over n. There's the sample size, square root. So just make sure to be very careful with your numbers. It's easy to make a math error. P times q over n square root. Hopefully I didn't make a math error. 0.0435. And we're going to make sure we multiply that by 3 and oh, wait. Haha. There we go. It's plus. Look at the equation. And I didn't. 0.04. I think that was right? Let me look at the numbers. Now, the way I like to do this is I keep this in the calculator. And I'm just going to go right here and add to it 3 standard deviations. I'm going to go to the mean of 0.63. And I'm going to go plus a standard deviation. I used my copy paste. So plus 1 standard deviation. 2. 3. We'll watch it again because I kind of did in a bad order. You ready? There's the mean. Great job, Kayla. And then plus 1 standard deviation. plus 2 standard deviations plus 3 standard deviations. Watch it again. Here's the mean. So there's the mean right there. Plus 1 standard deviation plus 2 standard deviations plus 3 standard deviations. And if this is about 4%, well, then they would be about 12% higher, or there's some change on there, so about 13%. So we are going that much above. Just kind of think through, okay, well, that's 4% times 3 is 12, so 75. Yeah, it's a little bit more. So just double check mentally to make sure things are looking accurate. Sometimes you can get weird numbers if you make an error. So with this right here, this is the percent of seats we would want. So if I know we want 76% of our seats to be non-smoking, what should I do to 76% to find out how many seats I want to be non-smoking? I know right now I want 76% of my restaurant to be non-smoking. So how should I find out how many seats? I know I want 76% of my restaurant to be non-smoking. I'd like 76% of my restaurant to be non-smoking. So how could I find out how many seats I want? Yeah. Writing down if you ever feel like there's a decimal error, please let me know. This one has a trick at the end, which I do correct for people because I think it's a little bit unfair. We'll talk about the trick at the very end. So I know I want 76% of my restaurant to be non-smoking. How could I then find out how many seats out of the 121 I want to be non-smoking? I know I want 76% of my restaurant to be non-smoking. How could I find out how many seats out of the 121 I want to be non-smoking? 76% of my seats I want to be non-smoking. I've got 121 seats. So if I have 121 seats and I want 76% to be non-smoking, I'll multiply the numbers. Great job, Kayla, right there. Yep. Now this one's tricky. What is the answer to the question? 100 points in the chat. What should Brian put as his answer to the question? 100 points. Brian should put what? And I want to point something out. Round up to the nearest whole number. I like the way this turned out this time because I could see someone getting this wrong very easily. It says round up to the nearest whole number. So a lot of people are going to be like, oh, I know the answer right now. This is where the mistake happens usually on this problem. 93. Round up. No matter what this is, you will round this up. Doesn't matter. Rock.
It doesn't matter.
That is 92.03. I know you're thinking, oh, that's 92. No, round up. It doesn't matter if this is 92.00001. It doesn't matter. You're going to round up no matter what. Round up. This is my answer. Pretend time right here. 92.001. The answer is 93. That's just the way this question works. It's the way this question do. And this is going to be 93. Not today, my Pearson. Not today. So that one right there is 93. You can't have 0.03 seats. So we round up. We kind of reserve that extra seat. We say, well, 92.03. We're going to round up and reserve that extra seat just to be a little careful. So it's kind of decent statistical theory, but it's a very tricky question there at the end, especially if you get what I got. You don't want to put 92. It will count it wrong. Not today, my Pearson. Today, my Pearson. So the answer is 93 because we are rounding up. Tiffany's question coming up right here. Let's go check it out. Chapter 14 quiz. A sample is chosen from a population that can be described as normal. Let's go check that out. Thank you so much. A lot of people getting some great practice in right now. Remember, this chapter is all about becoming that robot. I don't know if I like that new thing. I do the things to amuse myself. Hopefully I amuse you too. It's a lot of fun. Just, you got a lot of buttons to press, so you just press all the buttons. I forget what's down here. Nope, there's nothing. Nope. Watch this. Yo. I've got a weird mixing board. Okay, time to get serious. Put serious face on. Michael, we'll fix that after. Here, let's fix that real quick right here, Michael. We're going to fix Michael's thing really quick right here. You're welcome, Cece. We're going to fix Michael's thing. Michael, you're in today's class, right? Let me go fix Michael's thing before we forget. Michael, I think I see you right here. Michael, we're fixing yours. Tell me, Michael, if this fixes everything for you. Okay, Michael, you should be fixed. Michael, is that fixed? Are we good to go? Should be fixed. Let's go check out this new question. Michael, you should be fixed. Should be good to go. I lost the question. Chapter 14, quiz. And replace question. It's weird to find questions. I have to go in and look at all the questions. Tiffany said the question is, whenever we have time, can we do a sample is randomly chosen from a population that is described as okay. You're finding it. Here we go. Got it. Oh, it's a good question. Good theory question. Sample is randomly chosen. Chapter 14, quiz question. Let's check it out. Here we are. A sample is randomly chosen. It's still not working. Maybe email me, Michael. We'll get it fixed up. Reload. Try reloading it. I think I corrected it. So, oh, but no, check. You should have 100. I think I just give you 100 for it. Look, check it out since they're trying to fix it. What's the sampling distribution for the model? I hate that it shows that next question up there and blocks it. A sample is randomly chosen from a population that can be described by a normal model. What is the sampling distribution model for the sample mean? Describe the shape, center, and spread. Okay. So when we do this right here, the mean for the distribution of the sample mean will be the what? Will it be sigma over square root of n? Mu over square root of n? Mu or sigma? What will be the mean for the distribution of the sample mean? The mean for the distribution of the sample mean will be what? The mean for the distribution of the sample mean, the center of it, which is the mean will be what? The mean for the distribution of the sample mean will be what? It's on the screen. The mean for the distribution of the sample mean will be what? It'll be mu. So it's got to be mu, and that answers the other one. The other one is sigma over square root of n, which is the standard deviation. So you can see it on the screen right here in the equations that we wrote. The center of the distribution is mu, so that is mu right here, which is the mean, which is the center. So they're just using different words, and we do use the normal model to describe this if we meet the conditions. If a larger sample size is chosen, what is the effect on the sampling distribution? So if you go to a larger sample size, what happens to the mean? Quick question right here. If you go to a larger sample size, what happens to the mean for the distribution? If you go to a larger sample size, awesome, Michael got us working. Yeah, I thought that should fix it. And you're live, nice. Okay. Oh, that's why. Sorry, Tiffany. I'm sorry, Kayla. If you increase the sample size, what happens to the mean of the distribution? It stays the same, does not change. Kayla right there, great job. So it does not change. Doesn't matter.
It doesn't matter!
It doesn't change the mean. But what would change? What would change? It's starting to get like that. What would change about the distribution? What would change? The mean is not going to change. So the center of the distribution will remain the same. So the center is the mean. That's going to stay the same. But what does change about the distribution? What does change? What does change is the standard deviation. The standard deviation is going to get smaller. That's got it. Wait, what? Oh, submit the check answer. The standard deviation will get smaller. I was trying to submit the quiz right there. So the mean does not change because, once again, they're showing the equation right here. The mean has nothing to do with sample size. The mean is just going to stay the mean. The mean is always the mean because sample size is not going to change it. It's going to be the same consistent mean. But the standard deviation will get smaller by the square root of n. So if you see if n gets larger right here, it's going to get tighter and more normal. You know some stuff right there. So tighter and more normal, some points in the chat. I think it was, who had the next question? Was it Casey? CC? The next question was from CC. School referendum. Let's go check out the school referendum question. School referendum question coming up right here. We got open questions after this, though, so please put your next question in the chat. It is open questions after this. We have the school referendum question coming up. Open questions in the chat, though. We're just knocking out a bunch of questions today. Love it. Some days I decide to go more theory on the questions. Some days I decide, I never know what helps. Like, I never know, should I go through all the theory or should I like solve the questions? Do people get more out if I show how to solve them? Do people get more out if I do more theory? I need research. I need research on what helps students the most. That's my goal. And I think obviously people following along is the biggest help. Nice job, Tiffany. 100 points in the chat. Great job, Tiffany. Congratulations. Excellent work. My goal is to help you understand the material, and getting 100 is a good way to start. It helps with grades. Thank you so much, Kayla, right there. I appreciate that. School referendum question. Here we go. We got time for like at least maybe 3 or 4 more questions. Let's knock it out. Can we do the nearsighted? You bet. We haven't done that one yet. You got it. Abby, right after this, your nearsighted question coming right up. I know a lot about nearsighted because I'm super nearsighted. 2 eye surgeries. School referendum question. Bet you can't guess what we're going to do to start. Number one thing we're going to do while we got all these papers open right here is we're going to go right here and we're going to mark some notation. I'm going to do this one for you right here. So whenever you get a problem, you must make sure to mark the notation. And we only have two things to mark right now. We're going to go out and poll this many people. It says, suppose the budget has this, which this means it's the truth, which is weird that we would know this, but we apparently know the truth for the population is this. It's horrible handwriting. Yeah, thank you so much. Yeah, that's what I want, CC, right there. That's exactly what I want. And to try like solve along with me and be like, if you see it, and then maybe come back and resolve them and see if you remember the notation. Because then the better you get at saying, okay, they're supposing that the true proportion is this. Because they don't even say true proportion right there, or they don't say we know this. They're basically saying, suppose this is the truth. And that's the people who will vote for the budget. So these are the people who are not going to vote for the budget, which is the complement. So at this point, if you've been solving these along with me, you'd be like, oh, if we know P, we can instantaneously find Q. I always like to try to show every step because someone might be wondering, well, how did you get Q? Well, Q is going to be 1 minus P. So we just take 1 minus P and we get Q. It's the complement. If you know that, you're right there. You got this. The hard part about this question is, though, it says, suppose, what is the probability they predict defeat? And predicting defeat means we would see in a sample that a sample proportion would have less than 50%. So we're really asking the question, what's the probability in a sample proportion we would see less than 50%? So to solve this, we need to draw the sampling distribution to ask what might happen in a sample. And we would solve right here that mu p hat, what we expect to see in a sample, is equal to p. And we have right here, yeah, we do it on Tiffany. We got Abby's question, and then we got Tiffany's. You got it. And then we have right here the standard deviation. Say it with me along. P times Q over n square root. P times Q over n square root. And there we go. So we're just going to plug in the numbers. We've already solved. We already know what P is. We know what Q is. We know what N is. So we're just going to take these numbers, plug them in here. I'll do it below so we can kind of see. It's literally that the mean for the distribution of the sample proportion is equal to the mean right there, or the true proportion, which is still the mean. And the standard deviation, here we'll write this right here. Am I blocking it? No, I'm not. P times Q over N, and 373. Okay. And so there, I'm not blocking it. Just barely. It's barely not blocking it. And we go right here. 0.54 times 0.46 P times Q over N square root. Just make sure to carry your decimals. Make sure to do it carefully. Double check your work. That's a check on entering things into calculators. 0.0258. Who knows what we're going to go to now? 100 points if you know where Brian's going to go. Now that he has a mean and a standard deviation. I now know the mean and the standard deviation. I found the two quantities I want to know. I wanted to know the mean for the distribution, and I wanted to know the standard deviation for the distribution. So now that I know the mean and the standard deviation for a distribution, I'm going to go to the David M. Lane applet. Now you might be wondering, how would we solve this on a test? Well, the answer is we could look at the z-score. The z-score for 50% would be the following. To solve for the z-score, we would take the sample mean, what we're observing, and the true mean, the sample mean minus the true mean and their difference, and then the standard deviation. Now, the z-score for this is going to be something, and the top part of that equation is 0.50 minus 0.54 over 0.0258. It's going to be a negative z-score. It's going to be like negative 1.6 or something, maybe 1.6, I believe. So that's this, and it's negative 1.55. And that's just taking and solving that equation right there. So in truth, I've got a pretty good guess of the answer right now. I can maybe get this, and I'll show you how the answer, but that is something you, and so I'm taking a moment in my brain and trying to think. It's between 5 and 10%. It's going to be closer to about 5%. Is that going to be right? There we go. We got it. That's how you solve the question right there. Don't solve it like that, though. Only if you've done a lot of these would you know how to solve that. But once again, we did that without the applet. I'll show you how I knew that. Remember I found the z-score a moment ago? with that z-score, the z-score that I found, so if you want to solve it more like a test way, solve the z-score. This z-score right here, and there's the answer of 6%, is between a z-score of -1, and what's below -1? 16%, and between a z-score of -2, which is 2.5% if we use empirical roll. So I know some extra numbers that you wouldn't know, like 1.2816, which is going to be 10%. Is it 1.8? Is it 2.6? 1.4? Oh, it's 1.2. That's a bummer. Should be 10%. And I know 1.645. You're not meant to know these numbers, but that's how I guessed about 6%. So I know some extra numbers on the curve that help me guess percentages because I've done a lot of these problems. But a really great way to solve this problem is let's slow it down here. Hopefully I haven't lost anybody. What was the mean of the distribution? That's more of a test solve way down here. This is more of a, how would we solve this on the test thing? We might ask you for the z-score. So a lot of people say, well, how would I do this on the test? This down here in black is how we could ask a z-score question on the test related to what is the z-score for 50%. So we could ask you, what is the z-score for 50%? And that's a great way of asking it on the test to make it test relevant. But then what is the mean for the distribution that I found? The mean for this distribution is 0.54. So if I enter in the mean of the distribution, and then I enter in the standard deviation of the distribution, which I think I still have stored, that's the standard deviation, look where 50% is at. It's at the same z-score we saw a second ago, and that's the same answer we put in a moment ago. So you can draw it out either using the z-score like I did to start, or you can draw it out with the context, with the mean and the standard deviation, but this is the same thing. Watch as this changes. This is the same thing as using the z-score right here. If you look at this answer right here where it's at, it's the exact same thing as this. So you can see the same number, 6%, and we can do this right here. It's the same thing whether we do it with z-scores or we do it with the actual number, 6% and 6% with z-scores. So once again, I want to point out, this is more, a lot of people say, well, how would I solve this on the test without the applet? You could take right here at the very bottom, especially if it was a written test, which we don't do as many now. You could draw this out using the z-score especially, and go down here and draw that the z-score, which is how many standard deviations this is away, is going to be at right about here. That's where the z-score is at. And then this is the area on the curve. And this area would have to be between, it has to be less than 16%, and has to be more than 2.5. And that's how we could get an estimate of something like 6%. So it could become a multiple choice question. But right now you have negative 4.189. If that is your z-score, then, and was it like 55% was like 55 or 56% was your proportion? Because that would give a pretty big z-score. It must be a large sample size. If you have a z-score of that, your probability is going to be very, very small. CC, real quick, tell me your numbers. Tell me your P and tell me your N. So in the chat right now, we'll double check your work right here, CC, real quick. Then we'll do the next question. Tell me your P and tell me your N, and then I'll double check your work here mathematically. We're going to do a quick check on CC's question. So CC, go in and tell me your P and tell me your N, and then I'll solve it. I'll show visually what you have, because that seems really, it's going to be like 0.001. It's going to be very, very unlikely. So, oh yeah, that might be it. I think you've done it right, maybe. So the mean of the distribution is 0.55. And so 0.55 times 0.45 divided by 430 square root standard deviation. No. Your z-score looks to be right about here. The answer should be about 0.021. So you might have had a quick math error. That looked a little bit odd to me, CC, right there. So we're going to go below 50%. It should be about 0.021. It's 0.019, excuse me, 0.019. Double check your standard deviation. I think something happened with the P times Q over N square root. I'm going to double check mine. P times Q over N, 430. Square root. There we go. And so that would be it right there. Something might have happened on your standard deviation, it looks like. And so if you look, the z-score is very close to -2. That z-score sounded a little bit larger. To find the z-score, once again, take your observation of 50%, subtract the mean, and then divide by the standard deviation, and the z-score should be about negative 2.08. CC, great job. And thank you for asking, CC, so we can get it corrected. Calculator error happens all the time. It happens to me too. And great job, CC. Good practice on this problem. If you notice, it can be solved pretty quickly. Like if you know the rules on this, we could go right here. That one looks too similar. I was just doing the same problem. So I want to do like a different one. If you know the rules and you can calculate the z-score, it can be solved pretty quickly. I think it was Tiffany as the... No, wait, did we do Abby's? Nearsighted question coming up right here. Let's do that nearsighted question. Then Tiffany has the next one. Nearsighted question coming right up. Let's do it. We have not done the nearsighted question yet. Here we go. Some nearsighted question. Stat 201, nearsighted question. Let's do this. I dislike that it shows previous question right there. Okay. The central limit theorem applied to the sampling distribution of the sample proportion says what? Condition 1, random. Condition 2, 10%. Condition 3, pause, success failure, because we're doing proportions. So do remember that the third condition right here is proportions or is success failure because we're doing proportions. So do we have a random sample? Sure. I think assume that these children are typical, thus we've randomized who we're taking. Sure. The 10% condition and the success failure condition are met. Don't love this, but we'll just assume, make a quick assumption. How many standard deviations are they going out right here? Just want one number in the chat. How many standard deviations are they going out? All these curves go out how many standard deviations? A little easier to see right there. All these curves go out how many standard deviations? All those curves right there go out how many? 3. Abby, great job in the chat. 100 points. Go out 3 standard deviations. They go out 3 standard deviations. Now I want you to see something. What should be at the center of this curve? What should be at the center of all of these curves? Since we're doing the sampling distribution of the sample proportion, because we're asking, are you nearsighted? And the answer is yes, I am very nearsighted. Very, very nearsighted. So I'm always like this. What should be at the center of every one of these curves? The expected sample proportion, which is the mean. That is the mean. It is the mean is at the center. That is very true. And the mean for the sample proportion, which is what we expect, what should be at the center of all these curves? That is true. It is the mean. Because it's weird, because there's a lot of means. Like this is the mean of the sample mean is the mean. That's very weird to say. And it'll be P. It is P, because that's the P is the mean for the sample proportion. Like the expected sample proportion is the true proportion. So what's the true proportion? What is the true proportion? A really quick number in the chat. What is the true proportion? So if we know our notation, we can look at the top and say, oh, the true proportion is this. The true proportion would be this. What is the true proportion? I know, right? The mean for the sample mean is the true mean. Or the expected value when we take a sample mean is to see the true mean. 0.15, that is P right here. We don't need to solve Q. Oh, we'll solve it in a second. But one of these answers must be right, either D or A. And it's going to be A. D has too small of a standard deviation. Now, when you calculate this, you'll need to calculate 3 standard deviations. So let's go ahead and remember our formulas. So when we do this, we need to solve for Q. Who knows what Q is for this problem? So we're just finding Q right now because we're going to solve for the standard deviation. So I need to know P is 0.15. There's P. Going to plug that in right there. Q is the complement. So Q is 0. I don't know if you're looking at the chat. 0.85. I trust you. You got that. It's the complement. It's just what adds to 1. So 0.15 and 0.85 add to 1. So that's the complement right there. When you get to those problems, you're like, psh, got this. There's the sample size. And now I need to square root this. Don't forget to square root. Now here's the thing though. How many of these values am I going up and down on this curve? How many of these standard deviations I just calculated am I going up and down? We said it earlier, so I'll repeat it. We're going up and down 3. So 3 of these, I'm just multiplying it by 3, is going to be that. That's 3 of these. What's 15 plus 8? 23. What's 15 minus 8? 7. If you carry the decimals, it's going to be more exact. If you go 0.15 minus this, you'll get that. And if you go 0.15 plus this, and we're adding 3 standard deviations. Great job right there, Kayla and everybody. Excellent work. So we're going up and down 3 standard deviations right there. 3 standard deviations up and down. And this is the correct curve. Now think about this. if you would expect somewhere between 6.3% of children to be nearsighted, up to about 23.7% of children to be nearsighted, well, then how many would you expect out of 153? Well, okay, let's check it out. 23.66% of 153 children is very close to 36. 0.063%, which is the lower proportion I would expect out of, and we're multiplying because we're saying out of 153 children, this is about the lower end, is about 9.6, which rounds up to 10. So with this right here, these are the numbers of the lower proportion we found to expect multiplied by the sample size, the upper portion of what we would expect multiplied by the sample size, and that should do it. Not today, my Pearson. Never today, my Pearson. I think we have time for Tiffany's questions next. We got Tiffany. Let's do this. Hopping back right here. Does this make sense? Let me pause. Just make sure it makes sense to everybody. How are we doing on this question? Does all the theory make sense? This is a pretty good question. I like this one. Got a lot of questions today. How are we looking on this question? Makes sense? Like, cool. Know what's going on this question? Good stuff right here. Good question. Got it. Needy children, help out. You got this. Let's do this. Awesome. You're welcome, Abby. Tiffany's question was confidence intervals proportion chapter 13 quiz and homework. Oh, I think I might actually move it. Tiffany asked about moving that. I think I might move it. Which one did you want to do? Yeah, I'll be changing it. Oh, that was your question. We might end office hours. Do office hours end? I don't even know when office hours end. When do office hours end today? Because we'll be teaching here in a little bit. They end in 8 minutes. Let me go send out the reminder for class. I'm going to send out the class reminder so I don't forget. Got to send out the class reminder. Watch class live. This morning's class, I think, went so well. we hit the material so perfectly. I need to finish labeling videos. Class in 26 minutes. Class in 26 minutes. Big extra credit. See you soon. What I say every day. See you soon. There we go. Link there. Check link. Link works. 2 people waiting. Sent. Good to go. In 8 minutes. Awesome. Yeah, I guess. Are there any last questions? I might go grab a little bit of food or something. I just have pliers on my desk. Pliers. There's pliers? I think there are. We'll see if there's any last questions right here. Might take just a small break. But thank you, everybody. It's good to be back. More just 100%. Never want to go through painkillers again. But that's got it. Let's see. Assignments graded. Yep. Cool. What? I hate random emails. There. Cool. Fix stuff. I think that's got it. I might reply some emails, look through stuff right here. Great job, Vincent. Good to see you here. Ditto, good to see you here. Alyssa, good to see you here. Let's throw 100 points. We'll end office hours just a tiny bit early. We'll be teaching here soon. So I'll see you in class. You know, when you went over chapter 5, quiz 13, doing the restaurant. Yes, we did that one. Check out, we did it today. So rewind just a little bit in this video, John. You will see that problem. We did the restaurant problem today. So check out, you'll see the restaurant problem if you rewind. You can rewind this video live. So, John, if you can't find it, email me and we'll make sure you find the restaurant problem. But it is in today's video. Boys! With that, we'll be here teaching pretty soon. I'm going to go grab some food. But that's got it. Awesome. See you in class a little bit here. Bye for now, everyone. Bye! Class done. 25 minutes.